Hey everybody, it's Miss Austin and I'm going to be going over the Unit 4 Lesson 9 practice problems. You are going to need a calculator for this, your phone calculator if that's what you've been using. You can use Desmos. I'll be using the TI-84. There's lots of apps you can download onto your phone as well. So number one, ramps in a parking garage need to be both steep and safe. The maximum safe incline for a ramp is 8.5 degrees. Is this ramp safe? If not, provide dimensions that would make it safe. So we need to figure out how big is this angle right here. So today we learned how to use the calculator to find angles, right? So here's the angle that I'm talking about. I've got the opposite side and I've got the adjacent. Which trig ratio uses opposite and adjacent? Tangent. Now what's different after today is we don't know the angle. So the tangent of I don't know is opposite, whoops, I don't know why I wrote that, so 15 over 95. Now normally I know the angle and I type this button into my calculator. This time I don't know the angle, so I am working reverse. And on some calculators it says arctan, and some calculators it says tan to the -1, which means inverse. You might see this, or you might see this. Those mean the same thing. So I need to say, hey, I want to undo. Can you tell me what angle has an opposite of 15 over 95? So whatever button you're going to see, you're going to type that in. And it's going to spit out the angle. On this calculator, it's tan to the -1. That means inverse tangent. So you can see it right here above the regular tangent button. So second tangent of 15 divided by 95. This is basically what this is saying is, hey, calculator, tell me what angle has an opposite over an adjacent of 15 divided by 95. And the calculator says, hey, about 8.97 degrees. So that missing angle was 8.97 degrees. Now it's said to be safe, the biggest it could be is 8.5 degrees. This is 8.97. No, this is not safe. It says, if not, provide dimensions that would make it safe. Well, imagine, I've got to get up to 15, right? So I need to make this longer, right? I need to take more time to get up to that 15 to make that angle smaller. So what I would do is I would just keep trying different numbers. So right now this is 95. Let's try 96. So I'm just going to go second tan. Let me try 15 divided by 96 for the bottom horizontal distance. Nope, that's still an angle of 8.8. Okay, let me try, how about 97? That's 8.7 degrees. That's still not safe. 15 divided by 98. Yeah, nope. That's 8.7 degrees. How about 15 divided by 99? 8.6, still not safe. 15 divided by 100. Still a little bit over 8.5 because it's 8.53. So I bet you 15 divided by 101. There we go. So in order for it to be safe, this distance right here, right, needs to be 101 at least, if not bigger. This distance right here, which is that one right there, needs to be 101. Okay? Number two, ABCD is a rectangle. Find the length of AC and the measure of, oh boy, I can't remember what that Greek letter is called. I'll have to look that up. I know that's theta, but I don't know what that is. Okay, so we're just going to say x. Find the measure of x and theta. I'm going to change this to x because Miss Austin is having a mind blank and I can't remember what that one's called. So first of all, it's a rectangle, so I know this is 90. I've got the two sides. I'm going to use Pythagorean theorem, okay? 3 squared plus 12 squared equals, I'm supposed to find this, the hypotenuse. I don't know. I'm just going to call it h squared. So that's 9 plus 144. I'd add that on my calculator. or my head, and I'm trying to figure out what h is. So now I take the square root of both sides, and I will use my calculator for this. The square root of 153 is about 12.37. So this missing AC is approximately 12.37. All right, now it wants me to find these angle measures. Well, I'm going to draw that bottom triangle out separately. Let's start with this one, theta. This is 12, this is 3. I know this is 12.37 now, but I'm not going to use something I found to find a piece of missing information in case I goofed up, because then I'll get the second thing wrong. So if I want this angle, I've got opposite and I've got adjacent, which trig ratio? Tan. So the tangent of some angle is 3 over 12. Well, my calculator knows what angle that is. I just have to know how to type it in. So you're either, whatever way your calculator expresses it, it might say arctan, or it might say tan to the -1, that means inverse. I'm going to type that in. Hey, dear calculator, can you please tell me what angle had an opposite over adjacent of 3 over 12? Second, tan of 3 divided by 12. Now, angles in geometry, we usually, that first problem we were doing real life. I'm going to round my angles to the nearest whole number here. So 14 degrees for theta. So this is 14. Now, do I need to do all that again for this one? No, this is a triangle. I've got 90 and 14, right? The two acute angles in a right triangle have to add up to 90. I'm just going to do 90 minus 14. That other missing angle is 76. 76 degrees, 14 degrees. All right, number 3, find the missing measurements. Okay, so that means anything that's missing. Well, I've got this missing, that's my hypotenuse, and I don't know angle B or C. Let's find that hypotenuse first. I would use Pythagorean theorem again. 21 squared plus 35 squared equals I don't know squared. I'm going to type that into my calculator. 21 squared plus 35 squared equals 1666. I need to figure out what h is, not h squared, so I square root. So the hypotenuse is approximately 40.82. Okay, now I need to find the angle measures. Which one do I find first? I don't know. Let's find C. What do I have? I wouldn't use that to find the angle because I found that. What if I goofed up? I'm going to use the two sides that were given to me. So that's my adjacent and that's my opposite. Opposite and adjacent is tangent. The tangent of some angle is 21 over 35. So I need to ask my calculator, hey calculator, whichever button yours has, can you tell me what angle has an opposite over adjacent of 21 over 35? Second, tan, 21 divided by 35. Oops. And I'm going to round to the nearest whole degree, so 31 degrees. So angle C right here is 31 degrees. I got that from this, typing that in. Now, do I need to do all that again to get B? No. I can just do 90 minus that. 90 minus 31, angle B is 59 degrees. Now, if you found B first, you might, I don't know, what would that be? Sometimes the rounding, let's see, 35 divided. No, it would have been the same. All right, moving on. Number 4. Select all the true equations. So this is just back to setting up. So it says the sine of 27 is x. That's my adjacent over hypotenuse. Is sine adjacent over hypotenuse? No. The cosine of 63 is y adjacent over 15. Is cosine adjacent over hypotenuse? Yes. The tangent of 27 is y, which is my opposite, over x, which is my adjacent. Is tangent opposite over adjacent? Yes. 63, the sine of 63 is x, which is my opposite, over 15, which is my hypotenuse. Is the sine when you take the opposite and divide it by the hypotenuse? Yes. Okay, 63. Tan of 63 is y, which is adjacent, over x, which is opposite. Is tangent when you take the adjacent and divide it by the opposite? No, they got it backwards. It needed to be the x over the y. Number 5, what value of theta makes this equation true? Now this is something that we were supposed to cover, but you could still figure this out. We are going to cover this on Wednesday. If the sine of 30 is the same as, so way back when we first started looking at these trig tables, we realized that any complementary angles that added up to 90, the sine and the cosine answers were just switched. Now, if you weren't sure, you could just, right? This is smart test taking strategy. Take these answers and plug them in until you get one that's the same as that. So let me see, what is the sine of 30? The sine of 30 is 0.5. Now, they want you to realize that the sine of 30 is going to be the same as the cosine of the angle, right? If you had a triangle that was 30, I'm not drawing this to scale, by the way. So this would be 30, and then this would be 60. So the answers for the sine of this become the answers for the cosine of the angle that's complementary to that. But let's just go through if you weren't 100% sure and try. Let's put this in. What's the cosine of negative 30? No, that's not 0.5. What's the cosine of 30? No, that's not 0.5. What's the cosine of 60? Hey, there it is. The cosine of 60 gets the same answer as the sine of 30, which was 0.5. Number 6, a rope with a length of 3.5 meters is tied from a stake in the ground to the top of a tent. Okay, so here's some tent. And the rope is tied to the top of it. So see how it creates a right triangle. And the rope is this is the rope. The rope is 3.5 meters. Made a right triangle, and it forms a 17-degree angle with the ground. How tall is the tent? Now, my answers, I don't know if in your book, this is actually a multiple choice on the next page for the choices to solve it, right? Well, here's my angle. What have I got? I've got opposite and hypotenuse. Which trig function uses opposite and hypotenuse? Sine. The sine of 17 is opposite over hypotenuse. And then how would I solve that? I'd put a 1 under this, and the answer would be the sine of 17 times 3.5. So let's go look at which one of those choices is correct. No, it's not tangent. No, it wasn't cosine. And now there's sine 2 times, so which one was it? Did I multiply the 2 together, or was I dividing? Solve this the way I set it up, right? You're multiplying. They had the 3.5 in front. That's the same as, I just wrote it this way. Right? Same thing. C. Number 7. What is the value of x? All right, so first of all, let's take a look here. We've got 40, 50. That's 90, so this is a right triangle. Because remember, you can't use sine, cosine, and tangent unless it's a right triangle. And they want me to find x. Well, which angle do I use? You're always going to use one of the acute angles. It doesn't matter which one. I'm going to use 40. So what do I have? I have this side, which is the adjacent, and I have that they want me to find, which is the hypotenuse. Which trig ratio uses adjacent and hypotenuse? Cos. The cosine of 40 is adjacent, which is 3, over, I don't know. Put a 1 under this. So now we have 3 equals x times the cosine of 40. This time when I cross multiplied, x wasn't alone. I've still got one more step. It's getting multiplied by this. So I'm going to divide by this. Whatever I do to one side, I do to the other. Then I'm going to go to my calculator. What is 3 divided by the cosine of 40? About 3.92. All right, last one. We're not doing number 9. Find the missing side in each triangle using any method. Check your answers using a different. Well, the first thing I notice is that they've got two angles the same, 90 and that, which means they're similar, right, by your angle-angle similarity theorem. So I can set up a proportion. I could also just do Pythagorean theorem on that one, do Pythagorean theorem on that one. I'm going to do set up proportions, and then I'll check with Pythagorean theorem. So I know, let's find x first. So the side of the small one over, I'm going to do the bottom, right, because we have those two here. Over the bottom of the small one is going to be the same as the side of the big one over the bottom of the big one. Okay, now it's not the only way you could have set it up. You could have done 3 over 9 equals x over 12. You could have done 3 over x equals 9 over 12, as long as you're consistent. So now I cross multiply. 9x equals 36. Divide both sides by 9. X is 4. And then it says check. Well, if this is right, then 3 squared plus 4 squared should make 5 squared with Pythagorean theorem. Is 3 squared plus 4 squared equal 5 squared? That's 9. That's 16. That makes 25. What's 5 squared? 25. It works. Okay, now let's try this one. I'm going to set up a proportion again. This time I'll do the bottom and the hypotenuse and the bottom and the hypotenuse. So I'm going to say the bottom of the small one over its hypotenuse will be the same as the bottom of the small one, or big one, sorry, over his hypotenuse. So now cross multiply. 3y equals 45. Divide both sides by 3. The missing side is 15. Now I'm going to check using Pythagorean theorem. Is 12 squared plus 9 squared equal to 15 squared? Those are a little bit bigger. I'm going to use a calculator. This, when I add it up, should equal this. I'm just checking. Let's try it. 12 squared plus 9 squared makes 225. What's 15 squared? 225. Yep. All right, I hope that helped, and I will see you soon. Bye-bye.